So this is the gate previous question, and the question says this is a oscillator shown in the figure, and angular frequency of that particular oscillator need to be calculated, and the resistance of the particular circuit also need to be calculated. This is the resistance. This resistance. So two things we need to calculate. One is omega, and we have to calculate R. Before you solve the problem, we have to make sure whatever the oscillator is given to you, we have to make sure that oscillator need to satisfy the two conditions. One is A beta equal to 1. This is the first condition. And the second condition of the Barkhouse BH criteria, second one is the phase shift offered by the amplifier and the phase shift offered by the beta network should be 0 degrees or 360 degrees. So as we solve this one, before that this entire circuit we cannot solve it directly. What we do is we'll be trying to simplify it. So where I feel that a tank circuit is there across the oscillator circuit, what I do is I'll be like removing the tank circuit by observing the case when the circuit under the resonance. Let me show you how the circuit will be in the resonance and what happening under the resonance. So let me put the condition for the resonance when the tank circuit where have the capacitor and inductor offering the reactance by the capacitor is XC, and if it is the same value of inductance offered by the XL inductor. So if XC is equal to XL, under that condition, that particular capacitor and inductor will be in the resonance, so that what happening is whatever the energy is trying to deliver by the capacitor, the entire energy will be going through that. The charge is transferring, capacitor current will be flowing, that everything will be going through the inductor. So this is how the current will be flowing to the inductor. So nothing will flow over here across the other branches. So the entire energy will be transferred to this one, and after that inductor is taken all the entire the energy by the from the capacitor in the form of electric field to the magnetic field. That entire energy will be transferred again back to the capacitor. That is how the energy is shared between the two components. So in that way, once the energy is transferred and energy is received, positive and negative off cycles are repeatedly generated as an electrical signal across the capacitor. So this is nothing but oscillation. But to maintain the sustained oscillator, there is an amplifier is connected to the particular tank circuit. So now what I do is I will be putting the condition to generate oscillations where the tank circuit under the resonance X is equal to XL. So what I know is X is nothing but 1 by j omega c. It will be equal to j omega L of the inductance. So if I take it a magnitude, it will be 1 by omega c is equal to omega L. So omega whole square is equal to 1 by LC. Omega is equal to under root 1 upon LC. As the L value and C value is provided from the circuit, the L value is around 10 millihenry, 10 into 10 to the power of minus 3 into C value is around 0.01 micro, means 10 to the power of minus 6. So from these two, if I calculate it, the value it will be 10 to the power of minus 10 under root 1 upon that. It will be around like a 10 to the power of 5. So this much omega means angular frequency at which that oscillator is running. So I got that 10 to the power of 5 omega over here and over here. This might be a two options that I have. And coming to the resistance calculation, what I do is let me identify the new modified circuit where I will be simplifying the circuit with some modifications where I observed that the tank circuit is under the resonance. No current will be flowing into the circuit outside the circuit, and from the outside no current is flowing into the tank circuit, means it is totally detached. But whatever the oscillations are generated across the particular tank circuit may be provided, but the current will be zero across like other branches of the inductor, so that it will be like open circuit. What I do is I will be keeping a remaining circuit over here. Yes, so here I will be keeping my resistance R, and I will be having 1 kilo ohm over here. So I just remove this circuit, because like this circuit will not be connected with this circuit, because like no current is flowing into this one. So that like I will be having a simplified circuit. Once I get a simplified circuit, and putting these Barkhausen conditions and solving them will be easy for me. So that's what I'm trying to do. This is what my output. This is around like 100 kilo ohms, and this is around like a 5 kilo ohms ground. Yes. So as that entire circuit is divided into the two parts, where this is just a feedback network, and this is a amplifier network. This is my amplifier network. This is my beta network. And as I know, this is my op amp, where this is minus terminal, inverting terminal. This is the non-inverting terminal. And when my input is applied over here, and this is my input, and after I get output with the strength of the gain of the amplifier, it will be around 1 plus RF by R. RF will be how much? Is around like 100k by, and RF by R value is around 5k. So the overall gain is around 1 plus 20, it will be 21. I got it. So let me substitute over here in the Barkhausen condition, where the amplifier gain I got it around 21. And if you calculate the beta network gain, if it is the feedback value of the VF, and output of this one, it's like voltage divider network. If I solve this one, the beta will be nothing but a VF by V naught. If you solve this one, there will be voltage divider rule, 1 kilo ohm by R2 by R1 plus R2, 1 kilo ohm plus R. So this much beta you got it. Let me substitute that one also. 1 kilo ohm by 1 kilo ohm plus the R. This is what my beta value. If multiplication of A beta, it should be equal to the 1. So now if I solve this one, 21k is equal to 1k plus 1k plus R, and from this R we got it around 20k. And the resistance over here in terms of ohms means 2 into 10 to the power of 4 ohms. This much resistance we have to keep it. So this value is around 2 into 10 to the power of 4, so that it will be satisfying the condition A beta equal to 1, so that we can generate a sustained oscillations. So this is the value of 2 into 10 to the power of 1, 10 to the power of 4. So the option A.